Sounds good. Let's give 2 more minutes till everyone just joins a little bit and we can get started. Just 1 more minute. Okay, we'll just start now. All right, thanks everyone for joining me for this week. We are now in week 4. Today we're going to talk about architecture and RAG, what it takes to sort of build these out, these Gen AI applications at the back end. Last week we didn't finish off doing our chatbot, so we'll start off this week doing our chatbot, a basic chatbot today. Once we're sort of done what our basic chatbot configuration looks like in terms of loading to a notebook, running the code. Um, Next, after that, we'll just go to our slides to understand a bit more about these definitions, these terms. Please feel free to stop me at any time. We are a smaller group, so I can take questions on the fly and we can still continue. And at the end, I'll show you a couple of demonstrations of what RAG looks like in terms of pulling from a website and then using that as context, and also how to do a front-end page as well. So let's continue on today. So we'll start off with the chatbot. This is everything in the GitHub repo, and I'm just running these notebooks on Google Colab. So again, you install your packages. We're going to be using something called Panel. Panel is something that we can use inside Jupyter Notebooks, in which you don't have to have a chat interface built out or a front-end system built out to start having a conversation with your LLM. So we'll be installing what these packages are for or allow us to do it. Again, we're going to import our Gemini API key that we got from Google AI Studio. And for this model, we're going to use Gemini 2 Flash to make it faster. I'm changing the temperature 0 so I can get and ensure that the responses that I want are completely non-creative, because if I'm giving um, I'm getting this as well from it. Like, I need to know that it's not gonna do anything, right? I need to know that it's not gonna be creative with the instructions I'm giving it from. So when I run it, I have my functions, I have my system, and I have my system prompts. So I gave it an example, right? So you're an assistant that speaks like Shakespeare. Tell me a joke. So why did the chicken cross the road? Content, I don't know. So again, if you give that as a message, what would the response be when we run something like this? Oh, sorry, I think I gotta run this part. I know not the scholar make. Again, it's speaking like this because I told it that you're an assistant that speaks like Shakespeare. It's gonna tell a joke based off the information. And again, it's giving everything that we're talking about for. and speaking the way we're telling it to, right? So again, this is what's really happening at the back ends. You see ChatGPT or Gemini, they just have a nice front end that has a little box that says ask me a question. But on the back end, they have these system constraints. They have the temperature set. They have the top P, top K sets, the max output token set up, and that's how pretty much they're running from that side. So today we're going to be talking about how to create a chatbot. So this chatbot we're going to create first, we'll call this an order bot. So this order bot will take orders at a pizza restaurant. So if you had a website built up and you needed something that takes orders online, and you wanted to be more interactive, we can sort of build a chatbot for that. So again, we start our code by, remember, we're talking about being able to have conversations inside our Google Notebook. So we're importing our panel packages that we installed at the beginning, and we initialize our panel session. So what the context we're going to give to this LLM. So you are an order bot, an automated service to collect orders for a pizza restaurant. You first greet the customer, and then collect the order, then ask it if it's pickup or delivery. You wait to collect the entire order, then summarize it and check for a final time if the customer wants to add anything. If it's delivery, you ask for an address. Finally, you collect the payment. Make sure you clarify all options, extras, and sizes to uniquely define items from the menu. You respond in a very short conversational friendly style, and here's the menu. So again, we're giving context of what it's supposed to be doing, how it's supposed to be doing this, and also very specific instructions of the pricing. Now, this is why it's so important to have temperature at 0, because what if I put the temperature at 1 and I told it these instructions? When someone's like, well, how much a pizza is, it's going to try to be creative. And I don't want it to be creative at all with the price. And it could give a separate different price, could give out different things. So again, in order to alleviate that and to change that, we'll change that to 0 to 0. So make sure that we're not getting anything from that as well. So again, like I said, temperature 0, and then we start our model. So again, we need to do something that actually gets conversational history. In order to build a chatbot, you simply just can't ask one question and that's it. It sort of needs to be a snowball. You ask one question, you get your response, and then you ask another question. But the model should be taking into account all the previous conversations that's been happening. So in order to do this, every single time you ask a question to get a response, you need to collect these responses and then send that with the current with the new question that the user asks, right? So if this one said, "Hi, how are you? I'm from Brooklyn. I want to order a pizza." The model then responds, "That's great. What kind of pizza do you want?" "I want to order a pepperoni pizza." The model won't just receive, I want to receive a pepperoni pizza. That's going to be at the top, but it's also going to receive that beginning conversation of, hi, I live in Brooklyn. I'm trying to order a pizza. Everything needs to be sent to the model so it has that context in that. And this is what we do. We talk about collecting the message because we retrieve the user's input, update the conversation context, and then gets from the AI and then updates information. So we need to collect that information first in order for the model to understand a fluent conversation that's happening, because then it always needs to know what's happening. And as you can see, this does snowball in context, right? Because if you ask a question, all that response that I had in the past will keep adding to the input tokens, keep adding to the input tokens, and that does up sum. So when you do something like this, you should take in consideration the snowball effect of counting tokens when you do a chatbot, because it does take previous conversations. The only way around this is sort of to have another chatbot, another function that could rewrite the user response with the injected context. But again, you will be using another function. You will be using another LLM call. There is additional cost to it. So there are ways around it, or you can give a quick summary in 2, 3 bullet points. But again, you really want to find a ways if it's really that expensive to run something like this, or watching out for those tokens. So again, we're just doing something quick. We're just trying to get our context, our role as a user from the content. And then the bottom part here is just the information of how to run the panel. So we just run the panel, run it with the assistants, create the chat, and then that's it. So when I click run on this, it gives me a nice little button bottom part here. So it's saying hi. So let's chat with our chatbot that we just created. So I said hi, and I says, hey, are you ready to order some pizza? Please note that I did not say anything about how specifically the words it should say. I said you should first greet the customer. So this is how the chatbot is reading my instructions and responding. Hey, ready to order some pizza? But yes, I can order. Can I order a pepperoni pizza? So I said that. The model responded, absolutely. What size pepperoni pizza would you like? We have small, medium, and large. So I can write a large pizza, please. Okay. One large pepperoni pizza. Anything else for you? Then I could actually change that. Do you have anything with pineapple? So again, the model is going to look at the context of our thing. Like, fortunately, we don't have anything as pineapple as a topping. We have mushroom, sausage, Canadian bacon, extra cheese sauce, 8 peppers. So when you go back to our part here, and we talked about what are the toppings that we have, as you can see, I didn't put any pineapple as a certain topping in here. So although it's this customer wanted to have something with pineapple on it, the model is able to recognize, understand from the instructions that it doesn't have anything like that. So let's see if we can give something complete order. Like, when I ordered something here last time, I remember ordering something called a Canadian pizza. You know what those toppings are? And can we order this? Okay, so it answers, the Canadian pizza usually comes with Canadian bacon. I can definitely do for that too. So you would like a large pizza with Canadian bacon. What kind of pizza base would you like? Cheese or pepperoni? So again, it's gonna go and it's gonna try to order the pizza. So let's just make it really friendly. Okay, let's do pepperoni large pizza with Canadian bacon, please. Something like that, right? Sounds delicious. So that's a large pepperoni. Anything else you'd like to add to that? So it's going back to our menu. Let's see if we can add anything else we want. Oh, there's drinks here. So I can say, yes, please add 2 Cokes to this order, please, and give me my total. One large pepperoni pizza with Canadian bacon, 2 Cokes. Excess Cokes, which are like we have small, medium, and large. So I put small, and that's it. So let's just say we'll do delivery. What's your address? Oh, 123 Fake Street. I'd say pay cash. Okay, so I'll just pause here. So we gave it context. I threw a bunch of random information about it, pineapple that was not part of its context. I gave it context of something that I really liked, and if it was able to understand me, understand the nuances that I'm looking for, is able to recognize things from its menu, just suggest things from the menu, and then give me my total at the end. As you can see here, I don't think I specified that how I'm picking up pizza, how I'm picking up the money. So you can see that it added that as an extra item because I didn't specify that at all in the context window, right? I didn't say you can collect payment by adding cash, Stripe, pickup, whatever, right? But the chatbot is already assuming the role of an order bot. So it's assuming that this is going to happen next. And this is really interesting, and I really want you guys to play with this, right? This is simply just a simple prompt. I made this quickly within like 5 minutes, but if you did changes to anything in terms of creating your own chatbot, what instructions would you put in there? What identifications you would want? And really understanding how these chatbots in the history works, right? And if you want, you can add something extra like a token count that every single time that you run your message, where is that? How much is that token count taking account of, right? And see how much tokens this one conversation took in terms of doing this. So how does this work in a real world? So let's say you have this conversation happening and it's done, but how does it reach to your people? So how do we get this into a payment of system, a POS machine? Because a POS machine won't be able to parse this and see what's happening. What we need to do is sort of have our model then afterwards to go and create a JSON summary of this. So it's supposed to create a summary of the functions and orders of how many pizzas, the toppings, the drinks, the sides, total price, delivery information, payment method, exactly. So if I were to run this, we should be able to see exactly what we ordered above. So when you get your message and we get that chat history, guess what? We now have a JSON format. The type of pizza we're looking for is pepperoni. The size is large. They want toppings of Canadian bacon. They want two small Cokes. The total price is this. So then this is information that gets sent to a payment system that will show order ready for pickup, and then that gets sent to your payment system. Your payment system can take this, use this now, and then send the order to the cooks cooking in the kitchen. Send the order in your system as well, and save it in a nice organized fashion of what's happening and who ordered it and etc. Like this as well. So again, I just want to show you an end-to-end piece of actually creating your own chatbot by giving proper prompt engineering, giving it proper context. I'm understanding that this was just a 5-minute run and it was able to do something like this, right? But I can put it in this context many different things. Do not answer anything that's not related to pizza. For payment methods, only use cash. You could also write every single time that customer adds something, please give the customer a subtotal running what's happening, and please address all the questions that a user asks all the time. You can constantly think of ways to properly improve this chat model as you go through this. And that's something I just want to show you guys quickly of how a chatbot could work and how it actually works and connects at the back end. So again, please try this yourself because again, think of something you want to be doing for your capstone project. As we are now week 4, today I want to talk about a little bit more of your capstone project is choosing something that you feel like you can build. And again, it doesn't have to be something, a new code or anything like that. You can use any of these existing prompt books I gave you and just build something out yourself. Like, hey, I want to do an Etsy order page for t-shirts that I make, and I want a chatbot that could answer things. So then you can use this chatbot, adjust those prompts, and then when the capstone project comes up, show the changes you're able to do. The point of this is to really have you play around with it and actually build things that are very effective and build things that can actually help you understand AI piece more and be able to promote the things that you want to do with AI. So that is this section about the chatbot and really just giving it prompt engineering and context and how you can quickly create a chatbot on that side in which you can have a model to just train with itself and play with it that you can have as conversations. I'll stop right here if anyone has any questions before I can continue to this week's PowerPoints. All right, so I'll switch over to the PowerPoint meetings. One sec. Okay. All right. So I'm starting week 4, application architecture and RAG. So don't feel intimidated. This is going to be exactly what we're going to be looking at. So this is a new terminology. If you have any questions and you feel shy, just putting your hand up, just write things in the chat and I'll be able to respond to them as well. So how does a RAG architecture look like today and fully in production? And this is what's actually at the back end of a huge technological apps that we see. So what's in there? We have our data pipelines. So in order to do a RAG or in order to do retrieval augmented generations, you need to have documents. So example, like I said before, AI was trained everything on the internet, but let's say you have company data that's obviously not in the internet, and you want an LLM to understand these documents. So you need to have a data pipeline or a data set where these documents are living in. Once you sort of have where these documents are living in, we'll talk about next is something called embedding models, where you embed the documents. Because remember, LLMs cannot read and understand words. They convert these to vectors, right? So we know the embedding models, what they do is convert this to a vector store and convert these to vector lines, in which then it compares through similarity scores the text coming in because your input gets converted to a vector as well, right? It doesn't just say, I like shoes, goes to the LLM. No, that question gets embedded into a vector, and then whatever it is in your vector store gets and gets retrieved that way. The reason why RAGs exist, and going back to week 1 lessons, is that LLMs have a context window limitation. Remember we talked about OpenAI only had 250,000 or 130,000 context window. Gemini has 1 million. So what does that mean? These LLMs that are trying to read everything cannot read 2 terabytes worth of data that you have stored from your company server. It can read the biggest model can only read the size of a Harry Potter book. But if you chose 5, 6, 7, 8, 10 different HR policies that are 60 pages that are 100 pages each, you easily pass that 1 million context window when you know that your HR policies has over 100 different policies that need for it to understand. So it becomes a constraint. How do you get an LLM to actually read all this information and be able to provide you the right context? How can you bypass this if you have 2 terabytes of data that an LLM needs to read? And this is where RAG right now is sort of a band-aid solution. I call it band-aid because in the future, I believe LLMs will have a larger context window, maybe an infinite context window. Then we don't have to do any RAGs anymore. We can actually just point your LLM to all your documents, whether it's structured or unstructured, and be able to run it. But we're not there yet. So we need to find a way, and we do this by using typical techniques we did in 2018 with NLP. So before LLMs came out, and you had chatbots. So chatbots weren't new. Chatbots were existed, as you can remember, if you go to your bank and you're trying to have a conversation with chatbots, a lot of them were using Dialogflow from Google. A lot of them were using different ways of having the chatbot conversations, and they were based on rules. And the rules were that if someone were to ask a question, they would embed your question, typically the same way LLMs are doing right now. Your data that you're having gets stored into something called a vector store. And this vector store has chunks of documents that we'll talk about next. I get deeper into that. Chunks broken out of the document. So let's say you have 50 pages of text. So then you would chunk every 500 characters or every 1,000 characters or every paragraph into this vector store database that has your parts. So then when you ask a question, instead of having your LLM or having a retrieval read everything that's happening inside your vector store database, it does a cosine similarity score. So example, if you said, I like pepperoni pizza, and you have 1,000 documents, and from those 1,000 documents, 90% is talking about car and machines and factories. When it does a vector search similarity, it will find that the words pizza, things like that, aren't closely related to anything about car machineries. So it won't pick those chunks up because it's going to let those chunks go. What's going to do is find words or paragraphs or those chunks that are most similar to the user's question based off a score. And then based off the score, you can tell the LLM, okay, we can tell your functions to say, okay, choose the top 5 or choose the top 10 chunks that are closely related to that question. Why are we doing this? Because we're going to send only those 10 chunks that are very closely related to the LLM, and then the LLM will then decide, based off those chunks that was passed to it, what is the proper answer and devise that answer. So what we're trying to do is pretty much like a surgery. We're not trying to then pull up every information that you have. We're trying to find ways to sort of search through all your documents using that vector search, cut out only the parts that we need, and only use those to the LLM. That way, we're not sending 2 TB of data to your LLM and saying, give me what the best response should be. We're only finding those appropriate chunks and sending those chunks out to the LLM. So one, we can get a better price on our input context because those chunks get sent as input to the model as well. And that gets cost. And that gets cost. Remember, if we're talking about the API, anything that goes into the input becomes a cost, right? So we're trying to find what are the top chunks, what are the top values, and how to add those to your LLM, right? So this is why RAG was invented, and this is what we're going to be talking about more about today. But hopefully, it gives you a quick overview of why the need for RAG is simply because there isn't a large enough context window for LLMs currently, and two, your LLMs aren't trained on the specific data sets that you would need for this to work. So if we did that section of grabbing our data, embedding it, then putting the embeddings to our vector store database, we have a RAG, and this will go to our orchestrator or our main LLM. Now in the LLM, there's multiple different ways in production that happen. So this is just extra things for those who are very interested. I won't go deeper into these. I'll just talk about these very high level. But RAG isn't the only way to input information in. And remember, I told you an LM by itself doesn't know anything past its training date. So let's say you asked it what's today's date, and then needs to access a tool that it knows is not in the RAG, right? So it needs to have something that classifies the intent of the user. If your whole RAG's about your company and someone's asking about a date, it doesn't need to go to a RAG to pull that information out because a RAG won't know information about today's date because that's only company information. So let's say you have a tool, like we said last class, that is a Python function to get what today's date is and grabs that function, pulls it back in. Okay, cool. So I want to find out what today's weather is. Then you have an LLM that goes into an API, pulls out, connected to the weather network's API, gets the information from that weather network, and brings it back to your LLM. So you don't always have to have a RAG for information if you can use an API to access this information as well. Here we know that LLMs are really good at attention, and it's really good at looking at words and things. But let's say you throw a mathematical formula to calculate derivatives, it's going to try to guess and assume what you need to be doing, but the math is not really good at summing up the math or counting how many R's in strawberry, right? What you need to do is have a plugin that's connected to Python or something else that when you see a mathematical question coming in, it will then send it to these tools, have the calculation done in Python rather than having it done itself because it knows it's not good at math, and send the information back to the LLM so the LLM could say, okay, great. These are the functions, these are things that I've done, this is the response. And it's now validated by Python, getting the response back and getting those parts in. So this is why it's also important not only to have these different types of things, there's also these tools. Also, you would also have a context window. So we call this the playground, where you can give it a couple few examples. In here as well, there's caching. You can cache responses. And why would you want to do that? Because you want to lower the price of your LLM. If someone asked the exact same question before, and you know it's going to cost you 40, 50 cents to do this whole retrieval, if you already have that question cached in some sort of way, then you only ask you that question, retrieve the information from the cache, and then respond back. And it's going to cost you $0 because it's already a cached response that you know exactly one per one, right? And there's different types of caching. I won't get into it, but there's like semantic caching and there's different ways to look at it as well. This is where you would have that information go through. Then obviously in the productions, you have to log everything, ensure that you have a way to check what kind of responses are being done. And when you're in production, you may want to make sure that you can read and have an understanding of what type of responses are going out, checking for any biases, checking for people who are sort of abusing the system that way. Last part you would have to have is sort of these guardrails and also in evaluation. So in order to ensure everything that's going in information, let's say you have a guardrail set up that stops anything that's not being asked that are not cars related. So in your validation, you would have guardrails, and then you can check the logs and saying, okay, what questions are being passed by these guardrails, and what questions are not being passed by the guardrails, and is it doing a good job? So in the bottom, I put a couple of examples of what these are. Again, due to this class, this will be happening in sort of the 103 class of how to build chatbots with guardrails, loggings, caching, etc. But my job right now is to simply just walk through the basics of how can we have a RAG architecture. And then once you go in sort of 103, which is more an advanced class, how can you sort of add these last parts in. But my job right now for you guys is to sort of teach you how you can get this vector store and how can you sort of do an API plugin and how to do sort of that. How can we then show this to our front end? So going back to the principles, embedding models, and we see the embedding models here. We talked about this sort of 103. Our embedding models are very necessary in RAGs, right? Because you're gonna have information on like you can, and thing with RAGs, it can be anything you have in there, right? It could be PDFs, it could be emails, could be Word docs, could be anything with text. And you grab that information from the text. And this is the hardest part of RAG that most people don't understand is not the embedding model and getting the right responses. It's how do you extract the information from these PDFs? How do you extract information from these things? Example, some of them have charts, some of them are embedded images, some of them are that, right? So this is where really the hard part is understanding how to get that information out. There are different techniques called OCR, which is like a tree. Like you can sort of do what people are doing today, is doing OCR over these PDFs, which is optical character. I think character optical character retrieval. Which it does is have these they're models that are already trained on looking at images and be able to extract text from them. They usually cost a lot of money. There are open source ones that you can try to use yourself to pull these out. There are different types of ways to extract information from these PDFs, but again, those sort of be we can have more of a discussion like that during office hours or 103, but there's different ways to extract text. But typical, what most people try to do is simply just use a simple Python package. Could be PDF Plumber, which is a really popular one, or PyPDF, which then only extracts the text from the images and doesn't do anything, text from the PDF, sorry, and doesn't really do anything with the images. And most people are fine with that. They're like, okay, well, whatever, we don't need information from the images. We just want what's inside that PDF document anyways. But if you need information from tables and text, there are different ways to extract. And especially now, there's something called multimodal LLMs, which these models can now understand voice, can understand images, and can understand text. These multimodal LLMs, you can feed that to an LLM as well and extract text from images and text itself. So those are new emerging LLMs that can sort of do 3-in-1. But for now, we're only dealing with typical just normal LLMs that don't have extra multimodal capabilities. So again, I just want to point out is that when you jump to a RAG project, it could sound really interesting, but you need to figure out first, when I get into a RAG project, what is the documents that I need to pull information from? And how can you not overload the system? So this is where I look at this. Okay, so let's say we have only 3 PDFs that we need information out from, and they only just want the text. That to me seems like a really easy RAG to do and don't have to worry about much from there. So once I extract that text using one of those packages, like I said in Python, either PDF Plumber or PyPDF, I have this text now in raw format. Now, what I want to do is then chunk these text into proper chunks. Now, why do I need to chunk them out? Because again, if you have 30-page PDF and you want to do a chunks, let's say you have 3 pages per chunk. That means I would have 90 chunks for one PDF. Now, this is where it gets a little complicated because let's say on one page, you're talking about one specific context, right? So let's say you're talking about in one page, let's say that, like how to make a pizza or something like that, but in very big paragraphs. So in one paragraph, you have 80% of the ingredients. And then in the second paragraph, you have, okay, now that you've done this, don't forget to ensure that you add extra oil to the dough, or don't forget to leave it for 24 hours. You have specific things in that second chunk. Now, if you were to do chunking and you said, okay, I'll grab that first paragraph, it's 500 characters, that's great. My second paragraph will have this. If you don't, and then when you run your LLM, how do I make a pizza? It could be possible that you could only grab that first chunk, right? Because all the information on how to create a pizza is in that first chunk you have, but it might miss something on that second chunk, right? Because you're trying to grab only the information that's most relevant. And this is what we have something called a rolling window, where you can grab context, where you can say, okay, I only want 500 characters per chunk, but also do a rolling window where it grabs anything above that paragraph, maybe half the words, 250 from that one, and then also from below, from that second paragraph, grab another 250 from that bottom. So then it can sort of connect what's happening. And then if it sees that it's connecting to another paragraph that's really necessary, it will then pull that to the chunk. Sorry, so what I'm talking about right now is sort of chunking strategies, but I think it's really important for you to understand that before you start embedding and putting information into your RAG, you need to understand what is your chunking strategy after you extract your text from it. And you can extract it from 500 characters. You can make it 1,000 per chunk. You can make it as little as a sentence per sentence vector store, where you can describe things per sentences. But remember, the bigger you make your vector store, the bigger you make your chunks, your vector store needs to be able to handle that. And we'll get into that in the next two slides, because if you have bigger chunks, you need to have a bigger embedding model because it'll take a lot more space. So we'll get into that as well. And also, if you have smaller ones, you need to have a lot of space and a lot of memory, because now you're consuming more memory for having smaller chunks as well. So the typical and most standard is 500 characters per chunk. That's the typical one. But again, everything, you're like, okay, people ask me, okay, Luis, but what's the best way of doing it? And always the answer is depends. It depends. It depends. It depends. And this is where experience comes in, because it depends on on what you have. If you're just extracting emails and each email you know is under 500 characters, there's no point of you trying to do 1,000 characters per your chunks. Like, you know, your emails are smaller, so 500 characters is enough. But if you have a very large scientific paper which continues the same subject over pages, that will require a different chunking strategy, so you don't lose the context and the LLM knows what's happening. So once you have a chunking strategy, you're like, okay, what I'm going to do is 500 chunks, and that makes the most sense. I'm not missing anything. My next step is to then embed these chunks um, into our vector store. So in order to embed these things, you need to have an embedding model. So you typically use the same embedding model that you're using for your LLM. So let's say you're using ChatGPT as your main LLM. There is an embedding model that OpenAI has called Text Embedding ADA 002 that you would then use to embed your chunks based off that LLM. Because why would you want to do something like that? Is because LLM, your OpenAI or ChatGPT was trained embedding that exact same sequence on all those documents and knows what specific attention layers are. So when you do it on your documents, you sort of want to keep the same consistent format that ChatGPT knows, and then chunks them and embeds them that certain way as well. Because if you use another open source embedding model, yes, you can get very, very high and very close similarity score, but it wouldn't be good as if you used OpenAI's, because you're just comparing how the model was embedding, how it knows how it works. It was trained on trillions of data using the exact same structure. Yes, it can learn to use your open source embedding that you would have, but it's trained mostly on that text embedding. So when you do this, you also need to think about which LLM are you using for your RAG. Meta has its own embedding model. Um, OpenAI has its own embedding model. But like I said before, you don't have to use their embedding model if you're constantly going to go and switch to different ones. But there are open source embedding models you can use. But you definitely need to use this in order for you to have a proper RAG, in order for it, you can push raw text to an LLM. You don't have to do embeddings, but I say that's only if you have under, I would say, under 200 rows of data that are very small, right? If you have very small chunks and you think it's under your context window limit, and you're willing to spend a lot more money on getting that information into your LLM, then it's fine to skip the embedding models and just give straight small text chunks to your LLM and have it decide which one it wants to do better. Remember, there's always a trade-off from risk and cost. And this is something that you need to think about less as a programmer and more on the business side, because as much as things are very nice, whoever's running this needs to think about cost. And because LLMs and GenAI systems aren't that cheap, because depending on the structure that you use, depending on what strategy you have, it could be a difference of costing your company $1,000 per month, or costing it $10,000 per month because you didn't do a proper chunking strategy. You decided to give it full context. You decided to fill out 130,000 contexts per conversation. Apart from there, it really depends on how you are framing it in strategy. So you need to sit down with a pen and paper, sit down, okay, I'm doing a RAG. What's the LM model? What are the documents? What kind of chunking strategy should I use? What vector store should I use? All this comes with a cost. And I really go through this costing analysis in 102. on the 102 course, I go through um, how much text you should use, what's the typical cost, etc., and how you should really break down that out as a business, as sort of like a business analyst mindset. So again, I just want to bring you these new terminologies because as you go through this, and this may be the first time being exposed to these systems, that be very careful of the costs that do come with these models. Okay, so we already know what embedding models are. What's a vector store? So vector stores are specialized databases optimized for storing, indexing, and querying vector embeddings used in machine learning and AI applications. So they're like databases, but they have different types of indexing that they inside them. So what's the key features of these databases that make them different than the other ones? They make it easy for similarity searches. You can do metadata filtering on these databases. Their storage is scalable and they have real-time updates, right? So um, these vector stores are very similar as sort of as a table or a volume on a special on more computers. But again, their specialty is only to hold embedding models and embeddings in there and doing quick searches on it. And that's what they're designed to do. Sometimes these vector stores have different prices than your typical tables or volumes would have. And let's say Databricks or another thing in that sense because they are meant for search. Therefore, cloud providers decide to charge differently for these. So when to use these databases when you have a default, when you're working with general purpose applications that require similarity search or semantic search without the need for extensive customization, right? So it's going to include a bunch of things for you. And I said, you need to start thinking about vector store databases when you have tons of data that's be able to look at this as well. So when would you do this? Again, we talked about you would use a vector store for RAG, text classifications, recommender systems, anomaly detections, clustering and grouping these. And the point of this is that these vector store bases store high dimensional vectors. So again, the store your vector, when we'll talk about those, for those who don't remember from week one, is those lines of mathematical numbers with directional areas, right? That's what these vectors are about. And the point of it is to make sure it can do something very quick and rapid and run different functions on these vector stores. So let's talk about a couple of these different vector stores that are out there right now. So one is called ChromaDB. This is very open source. So you can install ChromaDB on your own computer and be able to run your own vector store very quickly and be able to grab your documents, embed them, and put them on your computer just today, right now, and then be able to start doing a typical RAG really quickly. So ChromaDB, very open source, very easy to use, but they don't have any cloud hosting capabilities. I think that was the last time I checked. I have to double check again because they always update these things, but they do not have any cloud hosting capabilities on that side. A very famous one, and a typical ones that I use a lot, is Pinecone. Pinecone this is a cloud-based vector store. So the difference between having something locally versus something in the cloud is dependent on your size of your data. So let's say you have 2 TB of worth of embeddings that you need to put on a vector store, and you only have a computer that's only 12 to 16 gigs of RAM. When you want to embed and do something that's very large in that sense, it's going to require a lot of resources of computer use for that, right? Because you're doing a similarity search across 2 million records. So the best way I would say for something that large is to put this on a cloud where it has customizable things, where it can have scalability, where it can be able to query those things. And again, if speed is an issue, putting things in the cloud is something that will increase that speed for you. And you can connect to your vector store database simply through an API call instead of hosting it and doing the whole things. you can send an API call to Pinecone to retrieve your chunks that you acquire most limited for yourself as well. So they have a free tier, very limited. The scalability is very high, very easy to use that way. Set this up, and they do cloud hosting. You can do local hosting as well with this Pinecone as well. So that's one big thing I use. Quadrant is something that I think I do a couple examples with. You can do it's open source, but it's optional to host it in the cloud as well. So you can put documents in there, pay a very small fee, and have your vector stores being hosted. So the Quadrant is sort of it's like a good mix between these two. Weaviate is another one, Melvis and Face. So Face is from Facebook as well. A lot of people talk about doing a lot of these RAGs with these open source vector store databases. So again, I give you these examples. So when you run and do your own RAG, and you're noticing that sometimes it may take a longer time for you to retrieve information from your RAG, it's taking you abnormally long time. You need to understand, well, is it how I'm pulling the data, or is it how my data is being stored? And make sure you look at the different vector stores out there to ensure you have the most efficient setup. So how do you evaluate a RAG? So you grabbed your data, you embedded it, you gave your chunks to the LLM. LLM is able to give a response. But how do you know that whatever's coming out is right? Yeah, you have something called gut check where you're like, that looks right. But if you actually pull up the PDF and you can see that it's actually it hallucinated and pulled this information up, how did this happen? If I'm putting 0 in temperature and I'm telling it in the prompt, do not hallucinate or make up facts, why is this happening? You need something more robust for these valuations. Or there's been situations where I've been pulled in where there's programmers who have never touched AI engineering before or haven't done anything about AI. They've come and built their own RAG, and in this RAG, they did their embeddings, they took the data, and they're like, well, how come it's not? And here's my evaluation. I used 20 questions that I synthetically built out, and the model was able to respond these 20 questions great, and they were able to do things. But when I go to production, it's actually giving the completely wrong answer. What's happening? What's happening? This is why it's important to have robust evaluations on your RAGs because yes, you can make 20 good hand-picked questions that the model will know, but unfortunately your users don't know what those 20 hand-picked questions are and will ask the model in the way that they seem fit questions about what they're looking for. So in order for you to do that, you need to find an evaluation system in order to validate what's happening with your model. So I'll give you a couple examples here, and there's definitely a lot more. But one good evaluator is called Ragas. It's an end-to-end service. It chooses different metrics such as precision, recall, and relevance. But you can add more now today. There's grounding, different things like that as well that you need to think about as you go through this. So how did I help this customer that was having that issue was that instead of having something that was synthetically evaluated, what we did was we had SMEs create over 100 questions that the chatbot must be able to answer and actually handcrafted the answer that the model should give. Now that I had something called golden evaluation, hand drafted by experts and SMEs that what the model should be instead of reading something gut checking, we run the evaluation of how the model responded in each of those 100 responses. And instead of getting that 90 or 100% that person was getting before, the model only retrieved only 60% of the questions that was actually being done. So the model accuracy was only 60%. Now that we understood that the model was failing, we can go back and understand, well, what was the chunking strategy? What are the different ways you're looking to pull the information in? Have you done anything else to make the RAG better? And this is why robust evaluations are really important because you need to be able to understand how well the model is doing and if it's hallucinating or it's not actually retrieving the right information. So again, I just left a couple of different types of evaluations you can do on this itself. So we talked about guardrails on that first slide. So what are some guardrails you can do for your LLM? As your LLM will be public facing or be chatting with customers, you definitely want to be like Gandalf on like Kira, not be able to give information from customers if you have that information in there. If you have sensitive information that someone shouldn't be able to access in your RAG, how do you stop that? And there's different ways of having guardrails. You can do something called an input guardrail that soon as someone asks a question, you can filter. Does this topic have any PII information? If it does, deny it. If a question is off topic, deny it. If this is a jailbreak attempt, as you saw with Lycara, deny it. These import guardrails are super important to be able to be used because these are going to save you the money. Although it may cost you 10 cents to run an LLM classifier on this or to run your guardrail, it's going to save you so much longer in the long run if someone's using your chatbot to do their physics homework instead, because they didn't want to pay for ChatGPT. They just wanted to look for an LLM, anyone who launched an LLM chatbot and didn't know how to do proper guardrail procedures. So this is one type of guardrail you can have, which is input. If it passes your input guardrail, you can then ask the question, and LM will retrieve it. Then before coming out and responding to the model, you don't have to have a guardrail only on prompt injections or off topics. You can then have a guardrail that says, hey, did you hallucinate this response? So then it will check the response that it did versus the information that it has in your context that you give your LLM or from your RAG. And if it checks that the chunks are actually responding to the LM response, it goes out. Or if someone was able to jailbreak and pass through your LLM and say you are now you are swearing Polly, you can check for any profanity in your guardrail and be able to do that way as well as anything with anything that has anything to do with competitors. So this is super important when you do something like that as well. Just one second. There you guys, my daughter went can say hello. So if you don't want anything to deal with competitor mentioning, let's say you are OpenAI and you want to say and you don't want someone asking questions about the LLM and saying, hey, what's the best way I can code? You don't want your model to say go to Claude. You can have a guardrail that says any mention with Claude in it, block it. So then either one, you have two options at this point. One, to retrain your model and give a better response with that output, or two, to say, I'm sorry, I can't answer that question. So these are something called inputs and output guardrails you can add to your chatbots, whether in RAG or not RAG itself. So again, I'll give you a bunch of examples of different guardrails you can use. One is Llama has their own guardrails that you can use on any other type of model called Llama Guard. There's guardrails.ai. You can do pydantic validations to ensure that everything's sort of pulled out in the proper JSON formats itself. Prompt layers, semantic kernel guardrails, trusts, LangChain validators, replicate guardrails, deep checks, OpenAI function callings. OpenAI now has implemented these guardrails. I believe Google, OpenAI have free guardrails that check against sexuality, profanity, language. So that if you don't want to make sure that your model is not saying something that's very inappropriate, you can call these guardrails for free on your LLMs to ensure that the output is properly done. Okay, so I'll take a quick pause here. We're about to go into what are RAGs. So I'll take a quick pause here. We are at the 1 hour, so probably take a quick 2 minute break and then we'll continue from this side. So see you guys at 12:02. Sorry, 10:02. Is it 9:02? I think it's 9:00. No, sorry, 9:04. I'm trying to think of California time. Sorry, is it it's 9:02 right now, right? So it'll be 9:04. All right, one sec. Okay, I think we are back now. I've got some glass of water and we can go from there. Okay, let me just get this page set up again. Okay. So we talked about rags, um, what we need to do and what we have. So in rags, we have four basic functions. We have a user's input that's going to be asking a question, and this becomes the query, right? Then what's going to happen is we're going to grab our relevant documents. So where it's going to grab our relevant documents is in our vector store. So in order to get relevant documents from our vector store, we need to have something already in the backend that went in, grabbed the documents, chunked them, and put them to our embedding parts. So when they ask the question of how do you evaluate the fact that CEO Sam Ultimate went all this information? What it does is converts this into an embedding, checks the embeddings in your vector store based through vector search retrieval. This retrieval could either be through cosine similarities, could be different types of ways to retrieve that information. once it grabs information, then it retrieves the relevant chunks based off that cosine similarity. So chunk one could be 0.98% very similar to the user's question. Chunk two could be 0.96 percentage related to the user's question. So there could be different ways, I'm sorry, uh, different ways of grabbing scoring on these chunks. So it's going to give all these chunks in here. So then when you give this to the LLM in the input, you give the user's question, then you give all these chunks to um, then you give all these chunks to your LLM to understand what's happening. Sorry, my mouse is very finicky today. So when you give now we go back to the LLM, combine the context and the prompts. So let's say the user's question, here are the chunks. The LLM will grab this and then now be able to populate an answer. So with the RAG, it's able to respond to all this information. Without a RAG, it will say, I'm unable to provide comments on future events. I don't have any information regarding this. Like I said before, it seems pretty simple, but when things fall apart pretty quickly in practice, retrieving the relevant parts of a very large data set, only using the information contained in a question is a pretty tall order. Depending on how the complex the question is, you might need to fetch information from multiple different parts of a data set and use and reference relationships in the data to find more information that can help you arrive at an answer. And you're always limited to the amount of information you can fetch. Even with expanding context sizes, reasoning and intelligence and models reduce the information you can inject into the input windows. Combine that with increasing cost, compute, and memory. Retrieving high qualities and lower quantities of information will remain a concern for the foreseeable future. This is also why modern RAG landscapes can seem scary and complex. All of them represent different attempts to solve the same problem. So what I'm trying to say is, as much as these may seem easier, some people might say, well, what's the alternative? The alternative of doing something like this is to fine-tune a model based off all your documents, but the cost is different. It may cost you only $500 a month, probably, or maybe less, 200, depending how much documents you have, to run a RAG in terms of including vector store retrieval information. But if you were to fine tune a model, it could cost you up to $5,000 to $15,000 one time run to fine tune your model, and to have all your documents set up in the LLM so that it could respond. And also, there's no guarantee that the model might not hallucinate even after you train the model as well. So with RAGs, you can do grounding, you can have input guardrails, output guardrails, and we'll talk about those different types of RAGs afterwards, that can really help make those type of responses more secure. So this is what we call sort of a simple RAG, in which you have a user question, you have the documents, you have the indexing, you retrieve the information, you ask a prompt. We call LLMs frozen because they're right now LLMs do not adjust to any idea, right? So even if you grab information from a RAG, it will never put that information into its training memory. It's always a frozen LLM. And then you get your proper response out. So then we have something called advanced RAG, which we talked about before. You can then do better things to get better responses. You can do something called query rewriting. If the user writes a question that's completely misspelled, it doesn't have the right context, you can use an LLM to then rewrite the user's question, to make a better response for your RAG. Can do something called query expansion, in which you can then ask 5 separate questions based off that one question, to your RAG to retrieve the best response, because of semantics, and semantics do matter. So the difference between semantics is what is Advil to Tylenol, or what it is a pain relief to with being pain relief to feeling healthy, right? There's different ways you can ask what you're trying to pull it out. How you need to imagine the vector store is a pond, and when you do your vector retrieval, you're throwing a line hook to your pond and trying to catch the biggest chunk, or that's related to your question. Now, if you're doing query rewriting, you're adding better context. For example, someone misspelled does this contain cancer, but spelled at CNCR, when you do your similarity search, it's going to look for that CNCR. It won't look for the proper word of cancer. So therefore, it won't find the right chunk. So you need something called query rewriting that goes and query and rewrites the user's question to something that's legible and that's actually part of your document. So when you fish for it, you can then find that right context. Query expansion is when you write something and then it breaks it to five different types of questions asking that exact same question. So then you're pretty much throwing five hooks into your pond at that time to retrieve the best response. So again, there's different ways you can do to also improve the chances of your RAG of getting the right vectors and different types of retrievals. Once you get your retrieval, there's also different methodologies. You can then re-rank your chunks using a context similarity API, or you can use an LLM to then re-rank the chunks that it has and say, actually, let's put these, let's say you graph 20 chunks. From these 20 chunks that came out from the user's question, you can use an LLM to then re-rank the responses based off the user's question, and then only use the top five. This is why you would want to use a re-ranker for, because again, you can't feed all that context to an LLM. You can then have an LLM read just to the chunks itself, then re-rank them, and then send the top five chunks that are most related to, and send them off to your LLM that could have it. You could also have an LLM, instead of grabbing those chunks, read the chunks that came out, create a quick summary, and then send that summary over to your LLM as well. There's different ways of creating your own RAGs. Like I said, there's infinite possibilities. Again, you need to find something that if you're finding that the typical RAG is only giving you very low accuracy based off your evaluations, then you do advanced RAG and you do these different types of advanced techniques in which you'll be able to then retrieve the information yourself. There's something called modular RAG, which you can then, as you can see here, the point of modular RAG is then it's constantly a different loop of retrieving, grabbing, re-ranking information, reading it. It's not actually giving the information out, then rewrite it, and then you go through these different circles to get the responses out. So what are the pros and cons of doing something, a naive advanced RAG? If I know I'm going to get 100% better answers in advanced RAG, why would I not jump to that right away versus naive RAG? And the reason is because of cost and time. So in the naive RAG, you could probably get 2 second responses, 3 second responses. But once you start adding query rewriting, re-ranking, summary, fusion, not only does your cost come up, because instead of having one LLM call being done, you're having one, two, three, four, plus your typical one, five different LLM calls being done. Each of these LLM calls cost money. And guess what? It also costs time. So it's not only so you're not only increasing of waiting 3 seconds for a vector search. Now it's taking you 9 seconds. How's it taking you 10 seconds? That someone's standing there and watching what's happening and waiting for something to happen. So that's something you have to be very careful about when you do something like this. Um, so as much as you get deeper into it, you'll then have to figure out ways how to keep it going and make it better. Then let's talk about when to implement these. So there's something called naive RAG. So the pros, simple to implement, requires minimal customization. Cons, limited accuracy for complex queries, lacked optimization steps, basic QA, simple for FAQs. So if you want to build something fast, something simple, like for a POC, naive RAG seems to be the best way to go. Advanced RAG, approved relevance and accuracy pre and post processing, but could be more computationally expensive, intensive as well, and could be slower, like I said before. When would you want something like this? When people don't mind waiting for the accurate response. I think a study came out that most people would prefer to wait 10 seconds or more for an answer rather than going back and trying to chat with the chatbot, trying to extract the right answer, although the answer might come out in 2 second time. So again, modular RAGs, again, what you're doing more advanced systems and you need different iterations and et cetera, et cetera. So Again, for you guys, try the naive RAG, and then 103, we'll be doing it more of those types of advanced RAGs. So how do we create a RAG? We first load our data. This is done through document loaders. Split the text, and we're breaking them into chunks, and then store them to the vector store. And then once inside the vector store, this is how they look like, right? They're through different embeddings that way. Okay, and then you retrieve the information from the retriever and you generate the chat. So in order to retrieve the responses from the chunks, there are different retrieval methods. One is through cosine similarity. This uses the dot product from your fractions. So again, in order to get something called the cosine similarity score, you need to sort of have ways to then validate what is the input text query is, and then which chunk is actually most related. You write in this function called cosine similarity, in which will show you what is the capital of France, right? You can see here that the word capital is being pulled in on a couple of these, so this is why it's having a very high score. And that said, capital is related to a country, so it's going to look for things that are related to something with countries in here. France is also a big word of attention. So you can see here, example, this one. France was actually caught as a big one because that got retrieved a lot of words. And you can see the word capital was caught in two other chunks, right? If I were to say only give me the top, give me only the four bottom chunks, like you only see that none of the right answers are in there. The top right answer is Paris is the capital of France, right? But again, that's at a very high cosine similarity score. So this is what I'm saying. You have to be very careful when you're pulling out these chunks. You should be able to trace what are the type of chunks that are being traced out? Why is it pulling certain words out versus the other ones? And how do we ensure that number one always stays the same of that? And we always get the high similarity score when you're doing these RAG searches. So here are different examples of doing advanced RAG retrievals. So cosine similarity score is pretty much your typical one that everyone uses. But if it's not good enough for you and you're seeing mistakes, then there's different ways to improve it. And these are the different retrieval methods that are out there. BM25, dense vector retrieval, sparse vector retrieval, hybrid retrieval, semantic search, and lexical retrieval. And what's really great about this, you can do something called hybrid. So you can do something called a hybrid search, which will use your cosine similarity and also use one of these mixed advanced retrieval. So let's say BM25 that's based off of frequency and document frequencies that way as well. So then it will look at the cosine similarity score, look at the BM25 score, and give you a hybrid score based off these two to get the best chunk. So again, you're looking at different ways how to do your best way to retrieval. Again, these are different, like I would say this, these are different ways of different rods in a pond, right? You can use BM25 as a different rod. Dense vector retrieval is another different rod. Hybrid retrieval, and I said before, using two different retrieval methods. It's using two different types of rods and then trying your best to get the best fish out there using the two rods, and going from there as well. The only thing you need to understand though, and one thing to watch out for, is that when you do these advanced retrievals, it's only dependent on the vector store that you have. So if you don't have a vector store that contains Elasticsearch or Lucene, you're not able to do BM25 on it. So example, if you were trying to do BM25 search using VectorDB, VectorDB is not an Elasticsearch vector store database, therefore you can't do a BM25 type of search on it. So this is why some cloud providers provide these type of things, like it's Elasticsearch vector store database. It has this, you can do this with that as well. Some of it is it a dense one, etc. Right? So depending on the vector store database that you have, either given through your company or one that you have to look for yourself, keep this in mind when you choose a vector store database. And the point of doing all this is to really get the best responses from your vector store database RAG. So like I said before, there's different ways you can chunk it and different ways when you embed your models, different sizes of embedding. So if you have very small text and you're doing one sentence embeddings on your vector store, you can do a very small dimensional size, small tasks, small data sets. So when you do your embedding model, you can set it what's the size that you're looking for. And then you put the size that you want in order for you to get the best vector store. So there's 128, 256, 512, 768, and 1024. 1024 is sort of your gold standards. That's pretty much it creates like 1,024 different dimensions based off your chunk that you're doing. And this is actually great for retrieval. But again, if you're doing 1024 embeddings on your vector store, guess what? They charge for that as well. So it's because you're using more resources to do something that's as big. Um, they obviously charge more for that as well. So what's a typical dimension is either 512 is your typical way how you would embed your model, which is complex queries rich data, enhanced semantic understanding, and but it also that has an increased cost, but you're still capturing all the semantics. So this is your typical base of when you're doing an embedding model to always set it to 512 to get the best way of that way. 768, if you have some ways to be able to encode it that way better. And of course, 1024 is if you have more resources. So I think I talked about this before at the beginning. There's different chunking strategies in RAG. There's a fixed size that you can say, okay, give me every 200 tokens or like a small paragraph. I want to cut off my document into these different chunks. Semantic chunking splits text based off semantic units. You need NLP tools in order to do that. Sliding window, I said, is really awesome because you can overlap different chunks to retain the context of what's happening. And custom chunking rules. So again, this is for chunks based on domain-specific logic. If you have one document that talks about different things at the same time, you need to have chunking rules that say, okay, chunk this section out only for this, and then label this with your metadata filters, this type of tag. And then for this part of this document, label this part, like you would have to create certain types of RAGs, right? So again, when you do RAGs, you have to think about your strategy. You have to think about how you want to go from there. And that is week four's lesson on architecture and RAG from there. Does everybody have any questions? I know I went through a lot in terms of terminology, methodology, and that works. Okay, great. Everyone's a RAG expert. Awesome. So let's go look at how this looks in a notebook. So again, this is part of our notebooks that we have on our basic RAG. We're going to first install our outputs. In this basic RAG, check what kind of version your LangChain community is. Because if you don't have 0.318, please run this line because it won't run because again, everything's based off versioning and to have it show you're using 0.318. Once you have confirmation that 0.318 is your LangChain community, you're able to follow the exercise properly. But all this is in the code itself already. So again, we're loading our LangChain, our models itself. We're going to load our Gemini API key. Again, we're going to do things very low temperature, 0.2. And then we're going to load our model. And then we say explain RAG, right? So this is something that we saw last couple of weeks. RAG stands for Retrieval Augmented Generation. It's a technique in large to break down accuracy, factual information, et cetera, right? So you can see here that the model knows about a lot of this information. That's good. Talks about hallucinations or instance where LM generates factual incorrect information, et cetera, right? So you need to ground this. So it's giving you pretty much an overview of what I talked about before, but LLMs do know this information from this side. So how are we going to do this? We first need an embedding model. So Gemini uses something called text embedding 004. So we're going to be using this to do our embedding model. So when you run our model from our engine, I'm going to tell this, please extract this model for us. And we do classification, for example. And we can click explain this RAG. What's going to happen is now it's going to use explain RAG, and it's going to embed this into an embedding. As you can see here, if you remember, this is how an embedding looks like. So again, when you say things or you explain RAG, your LLM model doesn't see the word explain RAG. It's seeing this embedding long sequence that you're seeing right here. Because that's how it's trained on, right? It's not trained on words. This is why I laugh sometimes when people are saying like LLMs have consciousness, they can understand me, they know what's happening, but they don't understand that it's mathematics and statistics that are happening in the background because it doesn't see the word explain rank, it sees these outputs of vectors that's happening. So once you understand that this is our embedding model, we're embedding this, we can have a custom class that we can have for us. So then when we start embedding things, we have it all ready to go. So let's build our first vector storage. So I'm going to be using Wikipedia for this. So I'll put this on our website here. This is the website that we're going to pull from to build our RAG, and we're talking about climate change. So we can see here, there's a lot of information on this. There are some charts information from that. And it's pretty much a long document, right? There's a lot going on in this page. So if I were to do Control A and Control C, and then I put here token calculation, let's say Google. Let's see here, token calculator. There's tons of things you can do here. And I were to then paste this in here, you can see here, this one's 54,000 tokens. And if I were to then send this off to OpenAI Azure, it's saying here, it's going to cost me about 10 cents every single time I want to run any questions, simply just on the information documents that I have that I'm pulling information from as well. So I don't want to be paying 10 cents every single time I'm looking at that context. I need to find a better way for my model to understand this and not cost 10 cents every single time someone asks a question. Let me just go back here. So we're going to have to build a vector store that only pulls out the most important chunks for this. So we load our imports. LangChain has something called a loader, which is called the web-based loader, which from the LangChain community, which is really, really good because then you can load your website in this. Be careful when you try to use different websites itself. In this loader, you're loading the page that says content. This is very domain specific to Wikipedia. So if you're going to add these different dictionaries and things like that, delete these lines and only use the website that you're using. Because again, this is going to mess up any other website that you're using itself. Then we're going to load this document. So this comes to where our chunking strategy happens. We're putting our chunk size to be 1,000 tokens. We're doing an overlap, where we talked about using from above and from below, 200. So that not only is it looking from the 1,000 chunks that we're doing, it's going to look 200 chunks up. It's going to use 200 chunks below. We're going to create our own vector store now. To create our vector store, we're going to be using ChromaDB. So from LangChain Chroma, as you can see from here, we're importing that package from the Chroma side. And we're creating a vector store called ChromaDB and create it. So if I were to look at my files, I should have something in here, but I don't think I have it right now. So because we're refreshing the page. So if I were to click show what's in our database, I ran this beforehand simply because it will take over a minute and a half, and I want you to be staring at a screen for a minute and a half. It will show what's in our database that way. So it's going to show all these different inputs that it just created itself. So you can see here, it went in, got different chunks from the text itself. Document 153 has this information. Obviously, the last bit of it has a lot of information that way, right? Document 87, policy options. Document 86, the politics of climate is this, right? So you can see here that it broke it out to all these different chunks that we wanted to and how we're putting them into our document and how that's going to look like. And this is why the chunking document strategy is very important because, example, I'm just doing this quickly, but it imported the text, the header, different formatting, all that stuff as different chunks, as well as the citations of all the different individuals who contributed to this. Does this really matter for my chunk? No, right? And again, but I'm simply just doing a simple exercise. I don't want this to, but if I were to do a production thing, I wouldn't want this to be part of my texting on my chunk or my vector store because one, it takes space, and two, it takes like it might confuse them all if I need to pull something out from here. So I'm going to create a prompt, and I want it to be very serious with me. Use the following context to answer the question. If you don't know the answer, just say you don't know, and use 3 sentences maximum and keep the answer concise. So that's my system prep. I don't want it to make up any information. So what's my question? So what is task decomposition? So if I go to my climate page part here, and I look up task decomposition, it's not going to find anything when I do Control F. So when I run this, you can see here, I don't know. The provided text discusses climate change adaptation, modeling, and history, but does not mention task decomposition. So to me, that's a huge success. I'm having the model create a RAG through the retriever to only answer questions that are not based off its trained information, only information that's trained on my RAG. So it doesn't matter if I ask that question, what's task decomposition, and it might already know it's an LM, it's a Gemini, it knows what task decomposition is. If I went to AI Studio right now and I ask that question, what is task decomposition, it's going to tell me. But because I'm restricted to only answer from my RAG, it's saying I don't know. And this is where I feel that the RAG is most successful once we get to this part. So let's do something that it does know. We know this is a climate change question. So climate change is an ongoing increase in global information. This includes climate change human activity. So it's pulling this information from this, right? If you ever want to do a quick check of how well it's doing as well, you can always do Control F and then check on certain words if it's there, right? So let's go. Climate change includes an ongoing increase in global average temperature. So we go back to our part here. So we could see that it grabbed that first chunk from that first text and it's able to actually pull the information from there. So this to me is really great work that we're doing. So this one, it won't know because I think I switched this to Wikipedia. So if I were to change this one to, let's ask a question about Industrial Revolution. So it's able to answer questions very specifically from here, from my RAG. Let's go ask another question from the bottom. Let's maybe ask one who is citations here. Let's maybe, because we saw it chunked all this stuff. Who wrote, maybe it's climate change, ocean heat content. Okay, so you can see that although we asked a question that could be in this Wikipedia, it didn't chunk this section properly, right? So that means Um, let's check this book here. Maybe it's not grabbing that side, but maybe it's grabbing this book. Let's double check if it's able to chunk the citations properly. Yeah, so it's not going to do this. So although it may have information from the document itself, if I try to go to the citations and pull information, it's not going to look at that properly. Okay, how about this one? We can ask this one. Okay, so it's not finding certain things with certain words on it. So it seems like, again, going back to our document, what is happening, why certain things can be pulled and why certain things can't be pulled. And this is where something you have to think about and look into your rags and get deeper into why certain pages that are maybe longer um, is actually happening versus it not. So you definitely want your model to say, I don't know, versus something hallucinating, right? So let's talk about El Nino. Yeah. So it's not going to answer things that are not related to that. So again, we have to be very careful on our text. This could be also a prompt issue that we have that should be you should be able to respond specific questions about this. Say future multiple warnings. So yeah, so it's able to respond basic questions, but again, this goes down to how you're going to prompt your context and how you can keep adjusting it. So I put one question here, how are we sure the model is using a RAG and not its training? So again, I think I gave that really good example already of this, of who's the author of this, let's say. Let's see who knows, let's ask who the author is. Yep, so that's what I found. It's not using anything that it's using from its training. And you can double check this as well. You can always go to your Google Cloud Studio, be able to ask questions. Let's use Gemini Flash, can make the answer, and see what, and you go to compare if it's using the LLM and see what kind of information it's pulling out. So this is why you have to be very careful of when you build your own RAG. Double check if it's not using its LLM memory or it's using only specifically to your RAG. And this is why I was happy with what it is as asking about certain things. It's saying I don't know. And again, this is something that I told it in its on its context prompt. Um, to say I don't know if you don't know the answer. So I'm just curious, what would happen um, if you remove that part? And I just took this part out, or your memory questions. If I change the retriever, yeah, even if I change the retriever, because the way we fold it right now is that We're grabbing the LLM, we're retrieving it. It first needs to check the documents there. If it's not in our retriever, then the LLM cannot receive anything to respond with. And this is why, although you change it to use some of this information, it's not going to give that, it's not going to give you that proper context. So I'll just pull this back. So Manoj asked an interesting question. What would changing the embedding model help with some of the misses? What are the models available? So that is on slide, I think I put it on. Yep, I think I put it on, I think it's on slide 3 of 19. There's different open source embedding models out there. There's text embedding Ada 002 from OpenAI. And there's a lot of open source models. You can look at Hugging Face that has it. So yes, so changing the embedding model based off your LLM could help with fixes and also help with misses as well. But again, it really goes back down to your chunking strategy. If you don't have a chunk that says something specific, um, example, we know that document 259 is a part of a chunk. If I go here now, in the article. So I think what it knows, it doesn't know that it has the vector store as part of its chunk. So I'm gonna have to ask something specific about this. Okay. Okay, let's see. So change back to I don't know the answer and predict. So it does enter some information from what's happening from that side, but it's not going to say there anything that's going to find based on information. So again, the citations are not properly cited in here, but we find out that the texts were. But again, play around with it. Use different Wikipedia articles if you like. In the example I put online for you guys, you can try to adjust the model. Sometimes even adjusting it to maybe 2.5 Pro, sometimes actually even gives better responses. But of course, when you do this, it's going to adjust how you're adjusting and reading everything, how you're parsing this. This will also change how you're reading this. I won't run this now because it takes over a minute to then store in store in our vector store database. But you play with the different models and see if you can get better responses using a smarter model. And that's one of the first things I always suggest to do is if you're not getting the best model on the Flash, because Flash is meant for speed and for writing. But if you need something that's smarter, use always a smarter pro models to get the better responses that way. So I always check that first before changing the embedding model in itself. Okay, and then the last example I want to do today with you guys is using an API search. How can you add that as a tool to a RAG? So let's install our packages. So in order to get an API key, go to tavly.com, get a free API, and you add that as a Tavly API key. So you go to your secrets, add that in there, and you should be good to go. So what is Tavly? Tavly is Let me just pull up the website here. Is a way to connect your LLMs to the internet. So think of Google Search API that when you ask a question, it's going to grab different URLs, combine them, re-ranks them for you, and then hand them to your LLM. And that's why I wanted to show this page because it gives you that nice quick visual of what it does on that side. So now that we have something that connects to the internet, we can then choose, okay, let's import our Tably, let's import our LLMs, and let's see if we can combine this data. But I want this to be a chat, so I need first to enable a history. Let's get some history going. Let's choose our model. We're using Gemini 2.0 Flash. I want the temperature to be 0. Don't be creative. Set up our API keys. Once you get this in. So this one, I believe I created last week, last class, because someone would ask a question if they wanted to grab anything from US news. So I can define the websites for the US news here. So Tably has a way to then only search these domains. So again, if you think Fox News has all this fake information and you don't want it to pull that from it, you can delete this from here. If you only want to only search certain domains, only search it from here. You can choose what domains you want for it to pull from. And then from here, choose the max most relevant results. I'm going to give it context. You're a US news specialist using only the following search results for major US news sources. Provide a comprehensive answer and impact, right? So only use information, roles, etc. So what is DeepSeek and what impact it had on the US? So when I ran that question through my response, AI response DeepSeek's a Chinese company, blah, blah, blah. US media coverage has this impact. Here's the impact that had on the market US. National security concerns, US media framing, and limited acknowledgement. While DeepSeek has significant headlines, the coverage is still evolving. And then it shows you the full history of how that's happening. So let's ask something that's relevant today. Back in the time, DeepSeek was something that was really popular today. So what's happening and what's popular right now is let's say coding agents. So what is Claude Code doing that is causing waves in the media? So let's run it. This will take a little bit of time because what's going to do is it's going to go to Tavily, use the API key, do those searches, and pull this information in. So let's compare this response. What is Claude doing in the media? Go back to our Gemini API key here, chat here. And I'm not sure if it's going to go on the internet or not here. Let me just double check. So it's giving me more about what it is, more of a technical background on the Google Cloud. But if I were to then go back to our Tavily search, so based on the provided searches, Claude is getting media attention in the US primarily due to the following reasons: copyright infringement lawsuits, ethical concerns of highway agents' behavior, New York Post. So you can see here that CBC New reports that Reddit sued Anthropic, scraping user comments to train Claude. You can see here that it's actually quoting specific areas and able to give that response in the bottom as well. And I can actually put something here in. It's interesting is like at the bottom of your response, please give citations. So it's able to respond, it gives gives talk about the different lawsuits, and now it's giving AP News, AP News, AP News. And I go to the bottom of this. Let's see if it gives me the information. Yeah. So it's giving me the company name, the URL, and the article that it's pulling from. So if I click on this, it's actually pulling me the citation of where actually the information comes from as well. So again, Tavily is really powerful in the sense that it's becoming a RAG in the sense that you're pulling information from the API to your actual information to your LLM, and it's giving it live information from where it goes. So this is great and all, but let's see if we can get this running on a front end. So I don't know if this will work. Hopefully it will, and that can show you a way. But in this code, what we'll do is we'll make a US News Chat AI bot. And we'll ask it, we'll give us some directions, tell us some queries here's some examples that you can ask, and then we'll run it. Again, this is everything that's inside your area. So you can click on a separate link. And now we have a front-end system, has some example questions to ask, and we can output our query here. So we can put in here, will RAG be obsolete in 2025? Let's see if there's anything in the news about this. So again, we got a response here. Here's a breakdown of what's happening. Talks about the difference of rags, different quotes, rag and a maple leaf rag, New York Times, blah, blah, blah. So based off the information search, this is what I found. Without more specific, it's impossible to get information from that way, right? Because again, rag is such a different words in LLMs. Let's see if I'm being more specific to maybe get a better response. Retrieval, augmented generation. As you can see here, we created a front end and literally, let's see here, in less than 1, 2, 3, 4 chunks. Have it. You can also play with it in the panel itself, or based off that link. And again, the Gradio site is very customizable, and be able to respond here, right? So. And this one now it's giving actually a better response on RAG LLMs are not safer. This is being explored. RAG is an enterprise AI. RAG and custom LLMs impact the median onset of American audiences. In conclusion, we don't know if it's going to be obsolete, blah, blah, blah. And of course, you can change this to be markdown format, but now we have different examples. You can ask different questions. I clicked the button from our examples that we created on this side. How's the US market change in months? Have that as an example, that as a button. When it ran, now we can see going back to our button, clicking on it, brought it here and answered our response as well. So this is how ChatGPT, all those different areas are using it. And you're like, well, I don't think LLMs are frozen because I can ask what today is. Well, it's because they have a Tavily API key, or they have some sort of other keys that is using the internet to pull the information and respond, right? So this is pretty much I want to show you guys today. So we created a chatbot at the beginning of class. We talked about RAG, the architecture. We walked through an example of actually using a Wikipedia page, importing that in to an LLM, and then using only the LLM to respond questions based off the Wikipedia page. And fourth and finally, the one we showed you is how to use an API call to go outside, retrieve information from the internet, pull that information in, and also how to build a front-end app itself. So you have all this information. You can change the context window of changing this to anything you want. Change the context of what kind of information you're looking for. You don't have to have this part here and including domains. You can just put search depth normal and then remove this. You can have it to look for anything it wants. change the Gradio. You can copy this code to ChatGPT and say, hey, make this Gradio look really pretty, or change the format to be white. I change the format to be the response all in the same box, like a text box, like a chat conversation, change it below. But then you have a fully functioning chatbot that has its own URL page that's connected to an LLM key and able to respond questions quickly. So that was today's class. Hopefully you were able to understand how quick and easy it is to develop something like this, but understand the nuances of responsible of AI, of not only you're responsible of generating accurate responses, and if it's your responsibility to also make sure that the responses are accurate. And for a business context, if you're not showing accurate responses, it's garbage, zero value to a business. So if you can create a RAG bot that doesn't have any metrics of accuracy, relevancy, grounding, things like that, then there really is no use case to use your AI function. You need to develop evaluations. You need to develop ways to evaluate how well your model is doing, either through citations, either through the evaluation frameworks that I went through today in those different slides. You need to show ways how you're evaluating your RAG with your golden data set and the golden sheet from there. So thank you everyone for joining me today. Just a reminder that next week is the long weekend, so there is no class from that. But I'll be here for any questions right now. I know that we missed out on Wednesday's class, so if anyone has any questions, I can stay back now and be able to answer them. But I'm here for any other questions, and hopefully you enjoyed today's lessons today. Thank you everyone for joining.
Thank you, Luis. Thank you.
So, Luis, I have one question. So, the Tavily response was very different to what the Google AI Studio has given, right? So, if we give the same context what we gave to Tavily to Google AI Studio, the responses would be similar. Can we expect that to be similar, or?
Yes, so if I went back and I copied this context, go back here. So we have a context system instructions at the top.
Right.
So you can put this at the top here, your US specialist. We go back to our Tavily search, only use these websites. Only use this website. And then copy this context as well. And then we can go back now and ask a question. What is Claude doing? So for this to work, we need to enable Google search.
Oh, okay.
So
Okay.
now that we'll have Google search enabled, we can run that same question. Because now it's going to go and look like Tavily, look at the internet. It has now the system prompt, has all the instructions, and see if there's different questions at itself. So did it follow what I said before? No. So it gave me a bunch of other context. So it gave me other citations. And maybe I have to put it here. Only use news sources when you do Google search. Only use these websites. Do not look at others. Let's see if it works as good as Tavily does. So let's see if there's a way to regenerate.
Question is gone.
No regenerate button on this one. It's fine. Let's ask again.
Nope. Same thing.
Yeah. So as you can see here, Tavily does have that restriction. You can restrict it to only these websites. And again, that is a plus from their side as well, right? So as you can see here, that as much as Google, as much as you can prompt inside a front end system, sometimes working the code in the back end is more. Um,
No,
you know,
the only concern I had on this one is Tavily, the responses were more like what are the restrictions and how it's going to affect the US economy. It is not showing anything about what Claude is doing and other things, right? But Google AI Studio is completely different. It talks about what Claude is doing and other things. So the response is completely opposite to each other in some shape and form. So I was wondering uh, why is there polar opposite? It all depends on the RAG and the LLM that is being used, or what is it?
let's see if I add this strictly this, and then let's see if it's able to give me something. Okay, so this one only found something. It's only using Forbes. I think this Forbes was one, not even on there. So again, it hallucinated.
Temperature is one, so it's hallucinating, I think. Yeah.
Try one more time again with temperature 0. Yeah,
Oh,
I think it's because right now it's going to grab from the history. So let's create a new chat. Which model did we have here? We were using, I think it was it Pro to be smarter. No, 2.1 flash. Let's see.
flash.
Yeah. Go to Gemini 2.0 flash. Temperature 0. Google search and let's run.
No, completely different. It's not even looking at what text we have given, like the Sai websites.
Yeah. So yeah, that's one thing you'll notice that on the front end, there's not a lot of controller as much as you try to give it to try to get the functioning. But I think this one works, our Tavily search works because again, based off this restriction, when we send the API out to Tavily, we're giving this restrictions
Right. Okay.
versus the other one. So if I were to remove these websites and then tell it to go to search, then we'd probably get the same thing based off it. But I guess there's so much negativity from these websites that the person pulled up, like the tablet pulled up the latest ones that were like that.
Yeah, true. Okay, got it.
Right. So in the tablet documentations, there's ways to remove it and add things like that, or you can copy and ask Gemini to how to fix that for that as well.
Okay, cool.
All right.
Thanks, Luis.
No problems. All right. I mean, should I state back any questions you have yourself or? Okay, we'll leave it as that then. All right, thanks, Manoj, or have some great weekend.
You too. Thanks, Luis. Bye.
Bye.
Louis, can you share the slides if you don't mind? I think we'll share it up along with the site.
Okay, sounds good.
Okay.